measuring the time that the clock gives you. So I think it's time to conclude. I would just recall you the example of the GPS. And I want to stress the fact that the GPS exploits quantum physics because these are atomic clocks, and also relativity because you have to make corrections for the fact that the time in the satellite is different from the time on Earth because of spatial and general relativity. So each time you use a GPS, think about the fact that you are doing fundamental physics, relativity, and quantum physics. And I give you an example in the future. What is called LISA, the Laser Interferometer Space Antenna. There is a project to send 3 satellites on an orbit around the sun, accompanying the Earth around the sun. These satellites will be linked by lasers. And by measuring the distance, the relative distance between the satellites, one hopes to be able to observe gravitational waves. When a wave coming from the collapse of a star, of supernova phenomenon, for instance, it will produce a ripple in space-time, and this ripple could be detected by this kind of antenna. This is a big project which will be sent in space in 10 or 20 years from now. What I want to say is that all these technologies were completely unimaginable by 1900 physicists. In 1900, there was a big exhibition in Paris, a World Fair, and during that time, postcards were printed everywhere in Europe to try to imagine what life would be now in the year 2000, 100 years later. And you see this kind of very naive pictures which extrapolate over what we know, what people knew at that time. So I always take this kind of pictures as an excuse not to predict what will happen in 100 years from now, because I don't want to be ridiculous even if I'm no longer here. So I will conclude by saying that it is hard to make predictions, especially about the future, as Niels Bohr said. And we have to use caution if you think about the 1900 postcards. But one thing is sure, without basic research, novel technology cannot be invented. In fact, all these novel technologies come from basic research. And the past teaches us that wonderful applications always emerge very often in predictable ways from blue sky research. And this kind of blue sky research requires 2 ingredients, which is time and trust. You need a lot of time to develop these experiments, and you need to have the trust of your leaders, of the directors of the lab and of the institutes who have to give you the time to develop what you want to do without asking for immediate results, and even without asking you what will you find, because one does not know what will you find. And research is fully successful where and when these 2 ingredients are present. I am thinking, of course, of Bell Laboratories, which from the 1930s to the 1980s have been very, very successful because they were doing this kind of research. And I'm afraid to say that it is not really favored by the laws of the global market, which emphasize speed and fast obtained marketable results, which is exactly the opposite of time and trust. Speed is the opposite of time, and the fact that you are asked all the time to write proposals in which you say what you will obtain in 2 or 3 years from now is the opposite of trust. So I think I just wanted to stress in this talk that, of course, we know that light is essential to life, to knowledge, and to consciousness. You need the information coming from light to build up our minds. Light, which can be either visible or, even more importantly, invisible, allows us to communicate, to be informed about the world around us and inside our bodies, and about the universe at large. And to come back to what I said at the beginning, the 18th century, which is a time when the notions of freedom of speech and of human rights were introduced by philosophers, is metaphorically and properly called the siècle des Lumières, the century of lights, and the values which are developed at that time are essential to allow imagination and creativity to blossom in arts and in science. And I think all what I said about the history of light is an illustration of that. And we thank you. Thank you for your attention.